Hi everyone, my name is Milad and today I'll be doing a system design practice exercise. I'm doing this to improve my skill set and hopefully in the process you learn something as well. Remember, whether it's this video or another video, always double check everything you hear or see. With that, let's get started. So, we'll be building a music recommendation service. What we want to do is generate and update user specific top 10 song lists, generate recommendations for each user, support a user base exceeding 10 million, efficiently process over 100,000 queries per second at peak demand. Okay, so I'd like to start off with finding out what my data would look like. And given the scope of this, I will be mainly focusing on user song activity. All right, and then we'll have a user ID, song ID, and counter. Okay, well, here's a question we need to ask. Given that the objective of this system is to purely provide top 10 songs and generate recommendations, I would probably say the best approach here is to use something like BigQuery. And if we're using BigQuery, what we would simply do is instead of having a counter, we would have a date stamp here. Because for each instance that the user listens to this song, we're going to have an individual insert into BigQuery. All right. Now, this is a service that's going to be used by an internal system. So it's not user facing, but rather backend facing. And for something like this, what we want to do is definitely utilize a message broker. And I'm familiar with Kafka. Depending on what you're familiar with, you could use whatever message broker you like best. This allows services to send requests to our service without having to wait for a response, because this isn't about getting a response back. This is simply about informing our system that a user listened to a specific song. Once we have that, what we want to do is process these messages as they come through. One of the things that we'll need to do is record that and store it into our BigQuery DB. So let's say this is, okay. Basically, we'll read from the Kafka message, read from a Kafka topic, and then write that to our DB. BigQuery DB. And BigQuery is really good for data analysis, machine learning, and other activities or processes that require data analysis. And this gives us an advantage by using this technology. Now, if we look at this, it's pretty straightforward. Read from the Kafka topic, write to the database. Now, if we didn't have such massive volume, this would be efficient. But what we need to do is be able to scale up and down as the volume increases and decreases. And to do that, we're going to build our service on top of a K8 infrastructure. Kubernetes is an elastic infrastructure that allows us to configure it to automatically scale based on certain metrics. And those metrics could be CPU usage, memory usage, and so on. So what we will do is have our service built in a K8 pod, and that will inside. So when you're building on top of K8 infrastructure, you usually wrap your services inside a pod, and then the K8 can automatically scale up and down your service by creating and destroying pods as necessary. So inside a pod, you'd usually have multiple services. One of the services you'll likely see is a metric service. And this is what K8 will use to determine the usage from that particular pod to determine whether it needs to generate more pods or not. And this would be horizontal scaling. K8 has a service called horizontal pod autoscaler. And what that will do is pay attention to the activity in each pod and based on that scale it up and down. This will allow us to not only meet current demands but also future demands automatically. Now there is a limit to this, and that limit is the actual physical server that this K8 node lives on. So there's a limit to how many pods it can generate before it doesn't make sense anymore. And to address this limitation, what we'll do is wrap this. We'll be building a cluster, autoscaler cluster that will automatically scale and introduce additional nodes each time the system determines that there's more activity than it can handle for the number of nodes it has. And whenever you utilize K8, whatever service provider you use, they will provide this service for you. And AWS, GCP, and Azure all offer these services. So all right, so now what happens here is that, let me get this. We have one or more instances of the activity service subscribed to a specific topic. Now, an important part of this is when you have a topic, you can partition it. And when you partition a topic, that means you're taking the data and allowing multiple consumers to subscribe to that topic and consume that. It's important to note that for Kafka, each partition can only have one consumer. That means if you have more pods than you have consumers, you'll have consumers sitting around idle. So what you have to do is, this is where business comes in, and you've got to do some level of prediction, determining, hey, what is the peak usage, and then creating some cushion and generating the number of partitions you feel you would need in the most ambitious circumstances given the current and trending traffic. So you don't just want to determine the number of partitions in the current number of traffics, but also what you predict the system will look like 3, 6, 12 months down the line if you don't want to revisit this consistently. And then we can simply write those, and as they're coming, we will write those to our BigQuery DB. Now these are transactional events, and BigQuery is designed to handle large volumes of data, and the numbers we're dealing with here won't really impact the efficiency or performance of our BigQuery database. So that aspect helps us create, and this service right here, what we see here, allows us to capture the user activity and store it for later use. Now what we need is a service that basically generates the user top 10 top 10 list. And to do that, we will build a service that is called user top 10. And basically what this is, it is a job that will process the data and generate a top 10 based on user activity. And then once it generates that data, we have to make sure that this is something we definitely want to populate in a cache service. And Redis would be ideal here. So what happens here is we run this job every, let's say, day, once a day, or if business decides more than once a day, we run that job, it generates the data and populates the Redis cache server so that it is accessible. Now, because this will now potentially be utilized by anybody, because it's now an endpoint, we want to make sure that this is not a single Redis service, but a cluster of Redis services. And once again, based on who utilizes this, if this is a user client-facing service now, we want to definitely distribute this across the globe in multiple data centers. And if it's not, we definitely just simply want to make sure that it's scalable so that as the requests come in, we can make sure that we can handle the load. But for the sake of this conversation, we can just pretend that this is simply an internal service, and these clusters will be located in one or two data centers. Regardless, we will still have a load balancer here. And as the requests come in to get a user's top 10 list, the load balancer will determine what Redis server it should go to, and then it'll retrieve this. Having a cluster of Redis servers gives us redundancy, and also if one server goes down, another one can quickly step in. Now, the next thing we want to take care of is the recommendation service. Very much like the top 10 service, we will have our recommendation service that utilizes some machine learning or AI model to determine what to recommend. And then based on that, generate recommendations. And then same as before, store it in our Redis server, caching it and allowing it for quick access. Now there are some challenges that can potentially come in here, and that is how resource intensive it is to generate recommendations and how fast business wants us to generate recommendations. Generally, this is a question of cost, complexity, and timelines. But each one of these recommendation services can be customized to business needs And then depending on how fast they want recommendations, this would be either scaled up, and depending how accurate they want that, it could be a really complicated process. All right, guys, let's take a look at the overall thing. Generate and update user specific top 10 lists. We do that. Generate recommendations for each user. We do that. Support a user base exceeding 10 million users. We do that as well. And then efficiently process over 100,000 queries per second at peak demand. And this is achieved by having the user top 10 service and the recommendation service write directly to a Redis caching service, wrapping that around building a cluster of Redis servers so that they're accessible and redundancy in case there's a failover. All right, guys, I hope you enjoyed that. Please let me know if there was anything that was inaccurate, if there was anything that I missed. As always, I'm trying to learn and improve, and this was my attempt at designing a recommendation service. Thank you so much. Have a good day.